Welcome to SSI Meetup. Today we have with us Joel Thorstensson. He's the founder and CTO of Threebox, which is a very cool startup from the New York area, but it's a very global team. And they've been working very hard on a new protocol, which is called the Ceramic protocol. And we had a chat with Danny Zuckerman, I think it was like October or November last year in 2019. And so it's great to have them back again. And this time with Joel, who will give more of a technical talk about what they're up to, what they're planning to do. And just let us quickly review in the next slide what SSI Meetup is about for those of you that are joining us for the very first time. So basically what we're trying to do at SSI Meetup is to help everyone share SSI knowledge around the world. And to do that, the way we try to do that is that it's open to everyone. So if you're an individual, a company, an association, anywhere in the world, you can reuse all the material that you see here at SSI Meetup. It's all shared with the Creative Commons by share alike license, which basically means it's open source, and you can reuse the open material. You can use the material in any way you want. You just need to give credit back to the person sharing it, which today is Joel from Threebox, and please also give credit back to SSI Meetup. And this is webinar number 57, if I'm not mistaken. So you have 56 other webinars with presentations and videos. You have the slide share already available in the landing page at ssimeetup.org. You will have the video after this webinar also uploaded, and you will have access to the Google slide deck. So if you want to do a presentation about ceramic, for example, around the world, you will be able to reuse this information. So that's the goal of this whole thing, what we're doing here. And if you have any questions during the presentation, please bring up your questions using the question tool. I'll bring up those questions to Joel during the presentation or at the end of the presentation, and then we manage the whole thing, so it's completely up to you. And without further ado, Joel, welcome so much to SSI Meetup. It's great to have you with us today.
Cool. Yeah, thank you very much. All right, so as mentioned, I'm a co-founder of Threebox, and today I'm going to be talking about a protocol that we've been working on for a while called Ceramic, and we're gonna dive into what it is and kind of what you can do with it and how it kind of relates to SSI and how it can actually enable SSI to kind of be more broadly adopted. All right. So Ceramic is a protocol for unstoppable documents. So what does that mean? So it's basically in Ceramic, you can create documents, and documents are usually owned by a DID or a decentralized identifier, and we'll kind of go into some of the details of that later. But basically, there are documents. They can be updated, so you can update the documents, and every update and change you make to a document are kind of verifiable, and you get like a version history of the documents. And you can think of this as kind of building like a document chain or like a ledger for each individual documents. And a document has like a permanent link that you can always refer to the same document. And all of this kind of lives in a decentralized network. And once we kind of have one or multiple of these documents, we can start forming like a graph of documents that kind of point to each other and give each other context and meaning. And interestingly, within this kind of graph of documents, we can also point to things like blockchain resources or server-side resources, or we could store like metadata about identities or non-fungible tokens or other things. The network, Ceramic network itself is public and permissionless and censorship resistant. And it also works kind of in an offline first environment if that's desirable. Updates to documents, I mentioned that they're kind of verifiable, and they're also anchored on a blockchain, which means that you have kind of way to prove the that a document was published at a specific time, or that an update to a document was published at a given time. And this can be scalable because we can kind of batch a bunch of updates into like one transaction using a Merkle tree. And finally, we have like a flexible account system within Ceramic. So that's called ThreeID, and it's a DID system that's built on Ceramic. And I'll kind of go into more detail about that soon. But yeah, ThreeID kind of allows us to unify accounts across many different blockchains. And what that means is that we can have kind of one identifier that you can kind of have to bring your data with you, regardless of like which application you might interact with. If it's like an application on like Ethereum or Bitcoin or what other blockchain you might have. Cool. So this is kind of like an abstract view of 4 nodes in a Ceramic network. So here you can see the triangles are nodes, and they have a few different components. So we can see that 3 out of these nodes have Ethereum, are connected to Ethereum nodes, and 3 out of the nodes are connected to like the Bitcoin blockchain. And then we can see kind of the circles around the nodes are kind of the documents that each individual node kind of cares about and maintains the state of. So once a document is updated and signed by an identity, this update is propagated over libp, and then all of the data within the document is synced over IPFS. And yeah, every update is also anchored in blockchains, as I mentioned. So in this example here, in this visual, you can see that documents that are anchored on nodes that only have kind of the Ethereum blockchain won't be like verifiable by Ceramic nodes that only kind of verify documents that are anchored in the Bitcoin blockchain. So you kind of have this kind of overlapping network where some nodes might have multiple blockchains that they kind of listen to. And natively in Ceramic, there is no persistence. So you have to like maintain the state of the documents which you care about, but you might want to like back that up on something like Filecoin or a centralized storage server, or there's like other decentralized data backup storage systems as well.
So, Joel, just a question here. I think it's pertinent maybe to the slide. Marcel is saying, are you planning on creating a network that itself relies on consensus?
Yeah, so it's so the Ceramic network doesn't really have a global consensus right now. Instead, the Ceramic network has like individual documents. You can kind of get an idea of like what the state is for that individual document, but you don't need to sync the entire state of like the entire network, because we imagine there would be so many documents within Ceramic that it would be unfeasible to sync the state of like everything. And this also makes the nodes kind of more light, since they only need to care about the documents in which they care about. So for example, here this node here to the left maintains 5 documents, and they're all kind of anchored to the Ethereum blockchain, so they can kind of check the integrity of those documents. And I can kind of dive deeper into kind of how that data structure and verification model works a little bit later. Cool. So what do we use to kind of enable this? So we use a few different technologies. One is called DIDs. So DIDs you may be familiar with, but they're basically it's basically short for decentralized identity or identifiers, and it's a standard that kind of provides interoperability for having a way of having an identifier that can kind of resolve to a document, and that document will contain kind of public keys and maybe some services that are involved or that is associated with that DID. So in Ceramic, you can actually store DID documents. So you can kind of represent DIDs within Ceramic, and we have a native DID method called ThreeID. But you can, maybe more interesting is that within Ceramic, you can create documents that are owned by an DID. So I can create a document that is owned by my DID, and only my DID is allowed to make updates to that document. Then we're using something called IPLD. So IPLD is a way to kind of store linked data that is linked through content addresses. And what that means is basically simplified that you basically link to other objects by using the hash of that object. So this is kind of the native data structure format that's used within IPFS. And yeah, you can kind of represent any type of linked data structure with this. And the cool thing is that you don't really rely on any kind of centralized service or any specific point that hosts your data. The data can be hosted anywhere. You don't really care about where the data is. You just care that the data is, you can check the integrity of the data. Then we're using libpdp. So libpdp is a network stack that's used by a lot of decentralized projects. So IPFS uses it. Ethereum 2.0 will use it. Other blockchains such as Polkadot or Filecoin also rely on libpdp. And you can kind of use that to discover other peers in the network and propagate messages using a native kind of PubSub protocol. And the libpdp also works in many languages and environments. Finally, we use a blockchain. Ceramic itself is blockchain agnostic. Right now, we have like an integration with Ethereum because that's kind of the blockchain ecosystem that we are coming out of. And the reason we anchor updates in the blockchain is to kind of determine the ordering of conflicting messages in a document if there are conflicting messages. And ThreeIDs, as I mentioned, is kind of the identity system that kind of allows us to unify accounts across multiple blockchains. And I kind of will touch more upon that later. So let's look at the autonomy of a ceramic document. So basically, when you create a document, you create this, or maybe highest level. So a document has a document ID. This is kind of an identifier that represents the document, and that's always the same. Usually, a document is owned by a specific DID. And when you kind of make updates to the document, those updates will be propagated or using libpdp. So in this diagram, we can see that we have version 0, 1, and 2. And so when I create a document, I create something called a Genesis record, which contains kind of the initial state of the document. And this record gets anchored on a blockchain, and we have some kind of additional proof metadata and blockchain transactions. So kind of all the, under V0 here, you can kind of get all of the data that's needed to represent this version 0 of the document. Then if I want to make an update to the document, so in the Genesis record, we can specify the owner of the document. And if that owner is specified to be a DID, we can then make an update to the document that's signed by the public key of that DID. And we'll now have the signature record, which contains the updated state or like the change in state to the document. And now we also anchor this this new update, and we get kind of like a similar data structure here. And now we have version 1 of the document. And we can refer to specific versions of a document by including the document ID. So the document ID is basically just the hash of the Genesis record. But if we want to refer to version 1, then we would say like document ID, and then also include the hash of the anchor record for this version 1 of the document. And then I can make an additional update, and I'll get version 2. So now if I only ask the network for, hey, what's the state of this document that has this document ID that's defined by the Genesis record, the protocol kind of gossips and tells you that, okay, the latest date is this update here. All right, so now since we can have this versioning and we can also check the newer updates, how do we actually manage if there is like a conflict resolution, or if there is a conflict at all? So the first thing we verify is like, are these signature records correct? If they're incorrect, then well, that's not a valid update to the document. But what if there are two signature records on the kind of same level as kind of version 1 here? What happens then? And they both have like a valid anchor record and both of signatures, but they updated two different things. And the reason we do that is simply the record or the update that was anchored the earliest is the update that will win. So if you have two nodes that kind of share the state of a document, and a third node comes online, they could just ask the network, hey, what's the latest state of this document? And if they get two conflicting versions of the document, they can simply like check which one is the valid one. All right. And here we have like signature records and anchor records. I think one thing I added here is like you could have different types of records. So for example, in the Ethereum space, there is this concept of a DAO, or decentralized autonomous organization, which is basically like a smart contract system that many people can kind of collaborate within and kind of share funds and decision making. So one thing we've been thinking about is we can have a signature record that's kind of a smart contract or a DAO that kind of decides that this is an update to a specific document.
I have a question here from Marcel, who's also related to the slide. He's saying, could you elaborate again what the Genesis record is? And is it the hash of the original file content plus some metadata?
Cool. So yeah, for sure. So the Genesis record is basically contains a few different things. It contains like the document type. So there are in Ceramic there are different document types, and I'm going to describe those in I think after this. And other than that, it contains like the owner, and it also contains kind of the initial content of the document. And then we just take the hash of that Genesis record that contains those things, and that hash is basically the document ID. So here and so that's basically the doc ID. Oops, doc ID, ceramic : / and then kind of the hash. Or actually, we're using something called content identifier in IPLD, which is basically like the hash plus like self-describing format for which encoding the hash has. Does that answer your question?
I think so. If not, Marcel, he's writing something. Yeah, he's saying yes. Thank you.
Cool. All right. So let's move on. So yeah, I kind of alluded to document types. So document types are basically different types of state transition rules that you can apply to a document. So actually, if we go back here, in the signature record, we kind of include some information about, okay, so how will we change the state or the content of the document? And in order to determine if like the signature is valid or that content is like allowed to be changed in that way, we use document types. So each individual document type actually defines the rules for the state transition of the document. And we have three kind of document types that we've created so far. And then you can add kind of your own document type if you have like different use cases or needs. So the first one is tile, and this is kind of the most generic doc type. You can put any type of JSON data into a tile, and a tile is owned by one or multiple DIDs. So you can imagine like you can store schemas in this. So you can have a schema that's defined in the tile, and you can have like updates to the schema. You can make like updates, and I can refer to a specific version of a schema using like the version parameter of a ceramic document. I could define policies. So I'll give an example of that later, but it could be a policy that describes like a service or some access control or some other thing. With Threebox, we're actually going to use the tile to store like profile information, and we're also going to store other types of metadata. And you can store, basically any type of generic data in this thing. ThreeID is the DID method that's kind of built on top of Ceramic that we have created. And ThreeID is really kind of lightweight and scalable. And it's also kind of maximally decentralized. So a ThreeID is basically just this document, and you only need to like verify like a very small piece of additional data compared to like other kind of DID methods that might live like natively on a blockchain or whatnot. And using Ceramic, we get kind of the secure key revocation system. Account links is another type of document that we have, and we use that to link blockchain addresses or blockchain accounts to a DID. And what this means is basically like if I have an Ethereum account, I can make a signature that includes the DID and kind of stuff that into this document, and that will kind of create a link so that I can find, given a blockchain address, I can find a DID that's associated with that blockchain address. So what we're doing with that for Threebox and Ceramic is basically linking together accounts. So you might have like an account on Ethereum, an account on Bitcoin, or an account on I don't know, Polkadot or something, and you kind of all point them to a same DID. So you can have like a generic way of kind of combining your identity into like one coherent thing, and you can kind of bring your data that with you across applications that might live on different blockchains. And you can create like your own doc type that defines the state transition logic for how or if the document is valid. So examples of this could be like a verifiable credential, or like a document that has like a dynamic rule set. So someone in our community actually suggested that you could create a doc type, or create two doc types actually. So like one doc type that defines rules for what the state transition for a document is, and then you have another doc type that uses the first doc type to kind of define its rules. So you have this kind of dynamic document that can kind of change its rules based on another document, which is kind of cool. So that's really interesting, seeing like what some people come up with on top of Ceramic. So I've been mentioning ThreeID for a while. ThreeID, basically what we're using ThreeID for is connecting all of these kind of different blockchains into one identity system. And the reason we want to do this is kind of we see a lot of value in the DID standard, and all of these different blockchains kind of either have their own kind of very specific DID implementation, or they don't really care about that and mostly care about like, okay, so I have like a public key or an address and I want to like make transactions on this blockchain network. But if we want kind of more interoperability across different blockchains, but also kind of with more other types of kind of self-sovereign identity systems, we kind of need this DID standard. And what ThreeID allows us to do is kind of connect all of the wallets and accounts that I might have across like multiple different blockchains into like one coherent identity system, where I can kind of control all of my data that I'm using across all of these different applications. All right. So in order to kind of achieve some of that, more on, or so the DID and those account links are like one piece of the puzzle. And then as we're kind of building this, we are creating a set of tiles. So tiles, as I mentioned before, is this generic data type, and ThreeID is the DID method. So we created a set of tiles that kind of describes a ThreeID account. And what that is basically a bunch of different metadata about an identity that is useful to kind of have for myself as a user, but also for other users to kind of get an idea of my identity and like interact with me in some way. So here we have the DID, and the DID can map to this account tile that includes mappings to other tiles. So firstly, we have this account links tiles, which basically includes all of the account links from different blockchains, blockchain wallets that I might have. I might have like a public profile. I might have some claims that I've gotten from some services. So that might be like a Twitter verification or like a GitHub verification or something else. A connection tile, I might have some like public connections with other people, like people that I'm like following or something like that. A keychain, so we can like keep track of the authentication methods that we have to the DID. This services tile can define different services that is associated with my identity. And finally, we have the sources tile. So the sources tile is really kind of what maps to your different data sources. You can imagine like an application creating data about the user and letting the user be in control of the data. So with ThreeBox, we kind of have this SDK that allows developers to store data with the user, so that the application developer doesn't need to care about where the data is. They just know that the user has it and is in control of it in some way. And this is kind of an iteration of this that allows us to kind of map different sources. And a source is really kind of some form of data storage that's stored, could be stored on a server, could be stored in a decentralized network. And we can map that to the user. And the user can have like multiple sources. So like I might have like a source from app A, a source from app B, and then I might have app C that kind of pulls in data from app B, A and B, and creates like a new type of application. And kind of what we have here is like a privacy policy that might describe access control to the data, and the collection is kind of like a tile that the application developer has described to kind of created to kind of describe the shape and form of the data that their application uses. Yeah, there's a lot of detail and nuances here. So we might go back to this if there are any questions later. Cool. So this account template is like an example of like how you can structure kind of user data on Ceramic. Another use case is that we can create service policies. And what a service policy is basically a document that describes a service that's provided by some service provider. So imagine you have a service provider that resizes images and provides the result in kind of like a linked data format. And this is probably some super simple API where we have like image.resize, and that's like API and resize image. Yeah, we have this description. So this is kind of the content of this service policy that would describe the service, and it has like a schema that describes the kind of data that you would need to send and what format that needs to have, and it might have like a response schema that describes the response data format that you're expected to get back. And this particular service might say, okay, you can use my service, but only if for every kind of request, you also make a micropayment using like a payment channel system to this address. So this is kind of like an abstract kind of description of a service. And the idea is with Ceramic, you can have like a lot of these kind of microservices that accept micropayments, and you kind of can use them freely as long as you kind of make these micropayments to the service provider. And since this is like would be like a public, since like Ceramic is like a public graph of documents, you could kind of do reputation and indexing to find like these different services on the network. And this service policy might include other things like various restrictions or like service level agreement or whatnot. And it might be like more complex than just like a simple REST endpoint. Cool. So Ceramic is development of Ceramic is being led by ThreeBox, and we're really kind of focused on creating a community that builds out this system that kind of allows for a lot of interoperability between like layer 1 blockchain protocols, and kind of also into Web 2 in general with these kind of service policies. So our kind of aim and goal is really to kind of create a connected metadata layer for this kind of emerging Web 3 that kind of also connects this to kind of the Web 2 broader ecosystem that we have today. And in doing this, we will also kind of allow users to have full control of their data and bring their data with them to the applications that they're using. If you're interested in like diving deeper on how the protocol works, we have a specification on our GitHub. If you're interested in trying it out, we have a CLI tool, and it's implemented in TypeScript, it's web native, and you can check that out at JS Ceramic on GitHub. All right, thank you all for listening, and I hope you enjoyed learning about Ceramic.
Thank you so much, Joel. So if anyone has any questions, please let me know. If not, I'll just kind of bring in my 2 questions right now. I mean, I have a couple of questions. how should you look at Ceramic? Is it like, I mean, if you take the Joel Monegro framework, the blockchain stack, would it be something like an overlay network? Would that be the place?
I don't know exactly which
oh no, because yeah, Joel Monegro, he just published something, I think it was like 3-4 years ago. It became pretty popular, like where you had like the root network, which is the blockchain, then you would have the overlay network, which could be something like Blockstream or Factum or something like that, and then and then on top of that, he would have decentralized protocols, and yeah. So but I mean, if you're not familiar with it,
interesting. Yeah. So I guess so. Like Ceramic would be like a decentralized overlay network, maybe.
Mm-hmm.
So if you see this kind of visual here, you have like these Ceramic nodes that are connected to different blockchains, and if my Ceramic node has like both a connection to Bitcoin and Ethereum, I can kind of sync and verify the state of all of these documents that are anchored on these 2 networks. And these documents might provide like metadata about like resources that live on chain, on the blockchain, or it might provide metadata about resources that live on a centralized server somewhere, or like some kind of service that I can like invoke or something like that. So it's kind of like a general metadata layer for the entire web in a sense.
Okay. Just one more quick question. I mean, I think you replied this before, but I mean, how does it become censorship resistant? Because you mentioned this in the beginning, and how does it work with systems? I mean, like, because most of the projects, at least those that I know that you mentioned here, they have some kind of a token incentive system. So how do these things like work together? And because some people sometimes they complain, oh, because Ethereum becomes too expensive, because when you have too much going on. I don't know. I mean, what are your thoughts in regards to that?
Cool. Yeah. I'm gonna go back to this one again. So the reason it becomes censorship resistant is that we're using this libPDP protocol, so nodes kind of connect to each other in a peer-to-peer manner. And if I care about a document, I would like pin all of the data of that document locally on my node. And if like that's not something that can be censored because I have the data locally. If there are multiple peers that pin the same document, then of course like that becomes more resilient. And you might choose to like back up the data on like an even more permanent system like Filecoin or Arweave or Sia or any of these kind of blockchain data storage networks. But really the censorship resistance comes from that you have this peer-to-peer network where nodes can kind of gossip about updates to these documents. And I mentioned that you kind of anchor or like you anchor the let's see, where did this go? You anchor documents on a blockchain, so that you can either like choose to like anchor one update yourself. That would, as you kind of alluded to, be very expensive. If every update I make to a document, I have to like make a transaction to anchor that. So what you would do in practice, in most cases, is that you rely on some service that takes a bunch of updates and creates a Merkle tree and anchors that with one transaction. So that is, you could view that as a centralized service, but it's not really, because anyone can spin up like an anchor service like this and just anchor updates for documents. And I'm not like limited by that anchor service because I can submit the transaction on chain myself if I really need to.
Well, what is the incentive for someone to become I'm not saying if I'm phrasing this correctly, but like a ceramic protocol node as part of that network?
So right now there is no incentive to kind of become a node like this, or like no crypto incentives, like no cryptocurrency rewards for becoming a node. It's kind of similar to IPFS in that way, that you can just spin up a node and provide content to yourself or to other people. But there's no kind of native incentive right now. As we kind of grow and scale the network and see like which use cases becomes the most prominent in this network, there might be a need or to kind of introduce some kind of incentive system to do something, like maybe that's persisting documents, maybe that's like responding to queries about documents or like indexing the network in some way. But we kind of don't want to like force a token model up on the network because that might like completely stop the actual functioning that it's providing.
Got you. I'll get back to it, but a couple of questions coming in here. One is from Ralph. He's saying, has Ceramic 3box its own DID method for universal resolvers?
So the question is if we have created a PR or like added it to the universal resolver.
I think it's both. I mean, I think it's like first if you have a DID, your own DID method, and then if it's also set up to work with the universal resolver.
Yeah. Okay. So yeah, we have our own DID method called ThreeID, which is based completely on the Ceramic protocol. It's not set up to work with I think the universal resolver that you might be referring to. We are using the DID resolver library that's in the Decentralized Identity Foundation repo. It's like a kind of generic JavaScript DID resolver, which you can plug in like any type of DID resolvers into. And that's also what we're using within Ceramic to kind of verify or like sync to state, or like basically resolve DID documents. So if your DID method also supports that DID resolver library, then Ceramic can kind of natively allow you to create documents within Ceramic.
Great. Then Marcel is asking, IPFS nodes have no cryptoeconomic, it's similar, but just I'm bringing it up. IPFS nodes have no cryptoeconomic incentive to provide storage. Is the same true for Ceramic? And then he's also saying, or is every user advised to run their own node? I mean, we commented just a little bit, but maybe you want to, yeah.
Yeah, I can expand on that. So yeah, as I said, it's similar to IPFS right now, where you kind of can start your node and you would like pin the documents and maintain the, or like watch for updates to any documents that you care about. Ceramic is designed to be web native, so the Ceramic node will kind of natively run in browsers, which means that you can run the full protocol within your browser, within an application, and kind of sync the updates. So we imagine that this protocol can kind of live wherever you need it in that sense. So if you're using an application that's enabled by Ceramic, then Ceramic would just be used in the background without kind of you needing to spin up your own node.
Great. I have Ralph, you raising your hand, but I think maybe you asked your question already in the system. If not, please just plug it into the system, okay? And then just unless there's any other question, maybe final question from me, because the approach that Threebox takes in regards to, I don't know, like the general identity space that is more people or things focused or organization focused, you seem to take a different approach in the sense that it's more about the documents, about how these documents are interrelated. Can you maybe expand a little bit on that, on what your thinking is, and how you think, or how you came to the conclusion that you needed to take this approach instead of taking, let's say, the more traditional identity SSI approach?
Yeah, that's a really good question, actually. So just for some context, so the founding team of Threebox were originally part of a different project called Uport, and Uport was kind of this identity and credentialing system on top of Ethereum. And what that was basically like you can go to some companies or governments or like civic institutions and get like a verification for something, maybe like a driver's license or whatever, and then you go to some other place and then you reveal that verification, and that's kind of the flow of that identity system. But kind of what we saw, especially like in the Ethereum ecosystem, like really what's needed to make decentralized and like self-sovereign identity a reality is kind of more focus on building application and like use data, use basically focusing on data, like associating data with a user, allowing users to kind of store and maintain their data and interact with other users, so like send messages back and forth, and not really focus on like these verifiable credentials that you use in like various kind of more kind of official identity. So the way we see identity is less that of like, oh, I get a verification from someone and now I have like my identity. Like I go to my government and get like my passport. That's I think is kind of the old way of looking at identity. And what we see with Threebox is more kind of this emergent or organic view of identity, where you kind of start interacting with applications and you interact with other people, and as you kind of start growing and generating data about yourself that yourself is in control with, that data and that kind of flow of data that you generate, that becomes your identity, and that becomes how you can verify yourself to different people and organizations. And that's really the vision that we've seen and that we're going after.
Awesome. That's great. Thank you so much for that clarification. So I think we covered all the questions. Thank you so much, Joel. Any final thoughts that you would like to share?
Cool. No, it's been great. It would have been fun to like see more faces and being a little bit more interactive. But yeah, awesome. And I hope you enjoyed it.
No, absolutely. It's great, and yeah, please keep us updated about progress you make, and if you want to jump over again, that would be great. For everyone else, if you want to watch the recording, please just check it out on the landing page. Just go to ssimeetup.org. There you will see this webinar, which is webinar 57 with Joel, and there you will be able to rewatch it or download the presentation. If you want to be informed for new SI Meetup webinars that we're doing, just sign up to the newsletter on the same website or join our Telegram channel, Twitter, social media, all those kind of things. The next one we have coming up is next week with Sam Smith. He will be talking about decentralized key management and with a method that's called Carry that he has been working on. And so really looking forward to that too. And Joel, thank you so much for being with us today, and I'll get this uploaded as soon as I can.
Yeah, thank you very much.